Welcome to the DCC Museum.
I'll introduce myself first. I'm Jac Goudsmit. I used to live in Eindhoven. I worked at Philips, so I'm kind of a fan of Philips too. You may know me from the DCC FAQ page that I wrote, I think 2 weeks before the demise of the DCC standard. I moved to the United States in 2000, and after that I also wrote the English Wikipedia page. What I'm trying to do with my project is to fix the things that you couldn't do with a DCC recorder from the standpoint of a hacker, of an electronics enthusiast, of someone who wants to do everything with a DCC recorder that you could possibly do. So for example, a pre-recorded DCC, it has a continuous table of contents, so you can always see all the tracks and titles that are on the album of a pre-recorded DCC. You can search by track title. The player knows which track is on the B side, so it knows to turn the head around and go to the other side to search on that side for the tracks. And it also has the ITTS information, which is the Interactive Text Transmission Service, which Ralph will demonstrate later, and which pretty much no one has ever seen. On a user-recorded DCC, you can record track titles on a third generation DCC recorder, but not on the first and second generation. And those track titles you can't see on the other generations of recorders. And you can search by track number only. So when it's playing track 1, you can search 2 tracks ahead. If track 3 is on the second side, it'll wind to the end of the side, and then it'll turn around and it'll start searching on the other side again, so it doesn't know where to go from the beginning. So basically what user recorded DCC tapes can't do is, first of all, those titles from the third generation recorders you can't see on the earlier recorders, and that's a problem. No recorders have that ITTS info. Every DCC, pre-recorded DCC tape that you can get has a little inlay card that has a little text in a corner somewhere that says DCC text on a recorder that's properly equipped. You can see the DCC text on this tape. Well, there was never any recorder that was equipped for DCC text, so it basically doesn't exist. When you want to record titles, you can only record them on a second go through the tape. So you have to record, if you want to record a CD first to a tape, if you want to put the titles on the tape, you can only do so by going through the tape again, searching through each track, and then recording it with your remote control. And with your remote control, you couldn't even enter all the characters. For example, the apostrophe was not part of the characters you could type, which is pretty much one of the most important characters of the English language, and you couldn't enter it. With the DCC-175, where you can do it with software, you can enter the titles before you start recording, and then it records them on the fly. Text data from a pre-recorded cassette, so the ITTS information, cannot be archived, because if you record DCC to another DCC or to a recordable CD, that text information does not get recorded with it. Ralph has been releasing DCCs from the DCC Museum. I saw that in the documentary yesterday too. And he had to pretty much use a DCC-175 to record a regular user cassette that looks like a pre-recorded DCC, but it really isn't. and there's a problem where you play them with the second generation DCC recorder. It skips through all the tracks because it's looking for the table of contents and it's not there. So next I'm going to give a little overview of how a DCC, the third generation DCC recorder works. The first generation DCC recorders were a little different because they had more chips, but basically they consolidated a couple of chips together in the third generation of the DCC technology, and they combined some chips together to make it easier to produce recorders. So first of all, of course, you have the head assembly, and it plays back to a reed amplifier, or it records from a write amplifier. So the reed amplifier and write amplifier are separate chips. Then there is the drive processor, which combines the error correction, the 8 to 10 modulation, which prevents errors. It formats errors, error correction codes on the tape. And when you play back, it corrects digital errors in the bit stream. It also controls the speed of the tape while you're playing back. And then these two chips, SFC and ADAS, are what decodes and encodes the pass compression codec. And then that is connected to the DA converter, the digital audio input and output, and the AD converter when you want to do a recording. Yeah. All of this is controlled by the main controller. That's a microcontroller, so it's basically a CPU with memory, with a ROM program. It's pretty complicated. It doesn't do everything still. There's still a deck controller that controls the solenoid on the deck. It controls the drawer, and it controls the reels to take up the tape and to supply the tape. Now, if we want to teach a DCC recorder new tricks, we pretty much have to, everything that gets stored on the tape is done by the DRP. So that's this big rectangle there. And the DRP is controlled by the main controller. So, well, it seems logical to replace the main controller and just put a different controller there and just program a new microcontroller and let that do whatever you want. Well, on second thought, that might not be a good idea, because there is so much functionality in that recorder, in that main controller. It's just too difficult to replace the whole thing. There's just the deck in your DCC recorder is the actual recorder. The front panel only sends commands to the deck, to the main controller, and that's really what does all the work. So this is a part of the schematic of a DCC third generation recorder, and it shows the main controller. The main controller is connected to the DRP via the L3 bus, and we basically need it to be out of the way, but only when necessary. So if we want to do things like fast forward or reverse or something like that, the main controller, we can just leave it in control, and we just stay out of the way, and the main controller still does its job. But when we want to, for example, record a tape from an SD card, or dump a tape to an SD card, or record titles or something like that, we need it to be off. So yeah, that's a challenge, because there's a lot of programming in there, and we need to just, it's difficult to take a controller with like 40 pins off and then sit in its place, but there's a little trick there. We can just put it to sleep, And then if we keep the other chips alive and working, then we can just take over the bus from the main controller, and then my Project 700 will just sit there and we'll talk to all the other chips while the main CPU is sleeping. By the way, Project 700 is based on the DCC, the Roman numerals for Roman numerals DCC are 700.
Okay.
So what have I done and where am I going? This is my living room. You saw it in the documentary yesterday for a little while. This is how I started out, with just the logic analyzer, the DCC recorder, one of my DCC recorders, and my computer. This is the main controller board in the DCC-730. It's also in the DCC-951, and it's also in the FW68, and also in the DCC-771, which was a dual deck that never got released. I read a lot of service manuals and data sheets of all these chips, and I figured out where all the points are where I can connect to this board and connect my own microcontroller, and ended up with a lot of wires sticking out of that board. And my DCC recorder looked like this. I have it with me. You can look at it later. Then I looked at a number of microcontrollers. This is the one that I'm using for the analysis part of the project. So I'm basically tapping into the bus, for example, to the bus between the main deck and the deck controller, the bus between the front panel and the main controller. And this particular microcontroller, which is the SAM-C21N, has enough I/O ports and speed ports to take a look at everything. But it has some other features there are some other features that it doesn't have that I will need a different controller for. So what I did first was I put a probe on the connection between the main controller and the deck controller, and I figured out what the commands were and what the responses were. I found out that the deck controller has a tape counter, and it also has the logic to determine very quickly, within 5 seconds, where the tape is. So when you put in a tape, within 5 seconds it knows that, for example, it's 21 minutes and 13 seconds from the start, which is really smart. This is a little movie that I made from the information that's going between the main controller and the deck controller. And you can kind of see the seconds counting up in that column. And you can see that there's a tape counter over there, keeping track of where the tape is. I also went to the bus between the front panel and the main controller, and one of the first things I found out was that one of the first things that the front panel does is it sends a deck ID to the main controller, and it says PHIL 0001 NL, which is probably Netherlands, 951 730, which is the two deck types that the main controller was designed for, DDU 2113, which is the number of the deck, and then U032, which is also the number that comes up in service mode that says which version of the software is on the deck. On this here, you can see that those here are still hexadecimal codes. I figured out what most of those codes mean, and we'll look at it later. I'll show you that I figured out pretty much all of the communication between the front panel and the main controller. What it also does is it actually sends view meter values from the main controller to the front panel. So if the front panel would have a view meter, it would actually just get those meter values from the main controller. which is actually kind of interesting. So I made a little program that shows those view meters, but if you do that, there's so much data going back and forth that it can't keep up, and I can only show that for a short time, and then everything crashes and stops and everything. But that's just because I'm actually showing it on the screen instead of just using it. So what I'm going to do is I'm probably going to use a TNC 3.5. The nice thing about that is that it's an ARM Cortex M4 controller, which is pretty popular, and it's pretty fast. It's in full production, and it's easy to get these things. That little board costs about $35. There is some extra hardware that I would still need, but I think I could probably make the hardware for about maybe $50, maybe $100 altogether, and you'll have a piece of hardware that goes into a DCC recorder of the 3rd generation, and will give you a bunch of extra possibilities. You can also see that there's an SD card. Well, we'll get to the other features. It runs at 120 megahertz, which is very fast. That's the main controller runs at 5 megahertz, so you have plenty of cycles left to do other stuff. The TNC it's 5 volt compatible. All the DCC decks run at 5 volt. Modern microcontrollers usually run at 3.3 volts, and they're not compatible with 5 volts. The 5 volt compatible controllers are getting very rare. It's got multiple serial ports. It's got multiple speed buses. And it has an I2S bus, which is compatible with the bus that is used in the DCC recorder for the pass data. So it would be possible, in theory, to copy the pass data to the SD card. This thing on the right is a micro SD card. So I can store your DCC tape on an SD card, which is pretty much what Albert was looking for in the documentary yesterday, if you remember. The microcontroller can do USB. It can even show up as a USB device. So in theory, it would be possible to play music from the PC and convert it straight into PASC and record it on tape. And it would probably be perfect to make dumps of DCCs as files and then play it back as MPEG files. So that's basically all the stuff that I already know is definitely possible. I'm also thinking of a couple of future ideas. So first of all, I want to make it possible to dump DCCs to a file so that we can archive the collection of the DCC museum. All tapes eventually go bad, so I want to make sure that that doesn't happen. So at least the tapes, we don't lose what's on the tape. The other way around should also be possible, so you can record a DCC tape from an SD card and record the text information on the fly. I'm also thinking maybe Ralph would be interested in controlling multiple decks at the same time, so that Carly can just start one DCC recording and it'll record 8 or 10 DCCs at the same time from the same data. I'm also thinking it might be possible to record audio in other formats so that we can put more audio on a tape. And there are some other ideas. All right, so the conclusion is that thanks to all the data sheets and all the information that I have, there's still life in DCC, and there's still a way to use DCC for the future. And this project can be used for adding missing functionality. Heads and tapes will be the problem of DCC in the future. When your head is gone, you just have to replace it by another head that already exists that comes from a different DCC recorder, and eventually we're going to run out of heads. Tapes, I think someone succeeded in putting a regular chrome tape in a DCC enclosure, and that gives much better result than just modifying an existing analog tape to play and record on a DCC recorder, because the DCC tape has some extra mechanics to guide the tape over the head, and I think we might be successful in making new DCC tapes, and especially in combination with if we would put a different audio format on the tape, it might be possible to just add extra error correction information, and that way if you get a dropout, you would still get the full music, because we have more space for dropouts, because we can compress better and use different audio formats. So that might be a way to lengthen the lifetime of the DCC standard. It may be possible to make a DCC 175 version of this project. I started actually on the DCC 175 because it has the external port already. It's easy to plug in, and there are lots of people who have a 175, but they don't have the cable to connect it to the computer. But I didn't get very far, but now I know more about how third generation recorders work. It might be possible to finish that project too. And then it might be possible to make a replacement for the missing cable for the DCC 175. I'm thinking next year or the next DCC convention, we'll probably be talking about the DCC 175 version of this project, or a new way to record audio to DCC and give a little longer life to ends and tapes. So I have a little demo. I have to set it up. If there are any questions, go ahead. Yes?
Are you going to release your source code and so on?
Yes, this is an open source project. I'm going to release the hardware design as well as the software as open source. It will be on hackaday.io. I don't know the exact URL yet. So the software as well as the hardware will be available. I don't know if it will be available as a product, but the information will be available definitely, so you can make your own, at least. Jeremy?
A company I work with that I use for a lot of the cassettes and stuff that I order, they have a lot of the 3M Cobalt tape left, but of course it's new old stock that they're running out of. And I was asking them about the DCC stuff, and I sent them one of them, and they looked at it and they think it's one of the higher end videotapes that were used in ADATs back in the days. Do you know if that would be an ADAT type of audio tape? You know, the ADATs from
I know
Alesis was making those?
Yeah, I know what ADAT is, but I think that's half-inch tape. So the question is...
Because it can be sliced, they said, and then they could re-roll it.
Right, so that is the question. Could it be, is it possible to slice a videotape and make it into a DCC tape? Yeah, theoretically it's possible, but of course you have to slice it very accurately, and you would need, you know, industry standard equipment to
This
do
company
that.
could probably do that. Yeah.
Oh, that's interesting.
And can that get Netflix? It seems to be able to do everything else. It's amazing.
Yeah. If we would have new, it's probably not too hard to produce DCC cassettes, because the mechanism, it's just a mechanism, you know. It's easy to bend a couple of metal strips and put it in a cassette and make it into a DCC cassette. It might even be possible to 3D print a DCC cassette. The little slider is not really that essential except for to keep the dust out. The cassette itself is not a big problem, but the tape is the problem. As I understand it, the tape factories that are in operation right now can only work with the ferro tape, so the type 1 tape, because the manufacturing process of the chrome tape is so dirty and is so involved with chemicals that they can't really use that process anymore with current environment regulations. So that means that if that is true, and I don't know if it is, then they can't produce chrome tape anymore, which is necessary for DCC.
We have a
because
lot
it
of
needs
new
the-
stock.
Right, because they need the low coercive properties.
Interesting. Cool, thanks.
Yeah. But that would be good news if there is a lot of tape around still that could be cut up.
They
into,
don't seem to be able to run out of it. Everything I ordered, they're like, yeah, sure. You know,
Yeah.
Possibilities are few.
That'd be good news. Right. Any other questions? Okay, thank you very much. So the demo is pretty much only the communication between the front panel and the deck, the main controller on the deck. And I translated all the commands that I know. It leaves out the view values because they just get in the way and they make everything, they don't make it. I can't show those fast enough to keep up with them. Also, it updates the time code every second, but I only update the time code when the track number changes. Otherwise, it would be way too much information. But the first interesting thing to show is when you turn the system on. You'll see that string that the front panel sends to the main controller saying Phil 0001 NL 951 730 DDU 2113 U 032. And then it says the function state is stop, and then it pulls the main deck. It continuously sends a command to pull the status of the main deck controller and asks what's going on, and the main controller then says, oh, something changed to the time, something changed to the switches, something changed to the marker detection, things like that. That also is a lot of information, so I only show it when something changes. For example, one of the first things it does is, a pull says the drawer, there's something with the drawer, an update from the drawer, and there's an update from the tape time detector, and then the drawer, so then the main controller gets the drawer status, and it's unknown at first, and then it gets it again, and then it says, oh, it's closed, so you don't have to close it. And then it says, what's the tape type that's in there? It's a pre-recorded DCC. All the tape types, I have to figure out what the tape types were, for example, but the service manual says that the tape types that it should show for each tape type, so I know what types I can expect even though I don't even have all the tape types. And some tape types don't even actually exist. For example, there's no 120-minute DCC, but I know that if there would be one, that it would appear as a certain number. So it reads the DCC to find out what's on there, and then it pulls again and it says, well, there's a change to the function. Now it says the function that it reads the function state, and it says, okay, I'm reading the tape. And then it pulls again and it says, I have tape time now, because it reads the time codes off the tape. And then it says there's a new function again, and it says, okay, now it's stopped because it's finished reading the tape. And then it tells the DCC, the main controller, that it wants to show the total time. And then it does a pull again, and then the controller says that it has the tape time. Okay, I'm going to switch the front panel to text mode now. And it says, it shows that I pressed the key, the text button. And now it shows the lyrics. See, sometimes it goes wrong. I have to turn it off and then start over. Read the DCC again. So here you can see that it's actually at the first track of the tape, and it's showing the text. It does a pull, and it sees, okay, I got the function state is stop, it pulls again and it says, okay, I got some other flags. I haven't decoded those yet, so there's 2 flags or 4 flags that I don't know what they are yet. And then it says get the long PDCC text, and it gets the track number of the current track from the deck controller, and it says space 1, and then a non-printable character, and then a la vie, and then another non-printable character en rose, and then it says get the short DCC text, track 1 la vie. So now on the front panel you can see that it says La Vie, that's the title of the track. So that's kind of interesting. You can kind of follow all the information that goes between the main track and the front panel and the main controller. For example, if I want to go to the next track, I push the button. You see that it starts winding. Function state goes to 30. I haven't decoded that yet, apparently. So basically, the deck is actually all the functionality of the DCC recorder is in the main controller, and the front panel only forwards commands and from the front panel, from the buttons, from the remote control to the deck controller. And the deck controller sends text information for the display back to the front panel. And so I know that all the functionality is actually in the deck controller, and you can't just replace that because you're definitely going to make a mistake. So I also did the same thing for the communication with the mechanic controller, the mechanism controller. That's a little easier. I showed you, it shows the tape time and a counter. So from this, I know that how to communicate. It would theoretically be possible to just take the deck out and not have a front panel, but use a computer or a microcontroller to control the deck. And that way we could make an installation with like 10 of the little decks of a 3rd generation DCC recorder, and then make a production unit that records 10 DCCs at the same time or whatever, and then all the tapes get controlled at the same time because they're all controlled by a computer. So that's how far I got, and that was my demo.
Easy access, and I could just put my probes on here for the logic analyzer and the oscilloscope. I made a little cable. I have to turn it off here. So normally this cable here comes from the front panel and has all the communication on it. That's normally plugged in here. And these connectors are still available, so I just bought these at DCC-i. So this is a male connector for printed circuit boards, and this is a female with the wires. And I just soldered these together onto a standard 1/10 inch header. And this way I can just break out the connection. I have a similar one somewhere in here for the connection to the deck controller. So this circuit board here has all the logic for the DCC recorder. It has the main controller, and it has the digital I/O and AD converter and a DA converter. This here is the deck controller. This controls the motor, the solenoid. Everything that the deck does is controlled by this, and it also has the counters, and it estimates where the tape is when you put it in. This circuit board is the read and write amplifier. So this unit pretty much is the entire deck, and all you need to hook up to that, it's totally modular, so all you need is some amplifiers and a front panel that sends the commands, and then this becomes a DCC deck.